All right, last section, 7:1. We have completely circled back around in chapter 7 where we started with multiplying and dividing, went to adding and subtracting, then we learned how to solve, then we went to graphing, and now we're right to where the beginning in terms of inverse and direct variation. All variation is really just writing an equation in terms of slope. Okay? You have two variables, okay, x and y, show direct variation if basically you have y equal to k times x. K is just a constant. Okay? The only thing different with this is there is no like y-intercept. Okay, so anytime you have any sort of direct variation, it's going to look something, it doesn't necessarily have to be x and y. If you just have y equal to 4x, if you have m equal to 1/3 q, that would be a sample of direct variation. You have one variable equal to another variable multiplied by something. It's not going to be direct variation if there is any sort of, like what you're used to seeing as 4x plus 3. That's not direct variation. Direct variation will always start at 0, 0. The easiest way that I can tell you as far as direct variation and something that you can understand is that it's like an hourly paying job. If you have an hourly paying job, if you work 0 hours, how much money do you get? $0. Okay? It's like your constant would be with whatever hourly rate. So if you get paid, let's just go with $10 an hour. Let's make it easy. If you work 1 hour, okay, your x would be like however many hours, or h, whatever you want to say. Like if we would write this in terms of direct variation, it would basically look like, let's just say, your wages equals $10 per hour. What's going to happen every time you work an hour? We're going to multiply that number by 10, right? Okay. Direct variation really, because you have no starting value. It's not like somebody's getting paid commission or somebody gets a salary plus money on top of it. If you work a regular hourly paying job, you work 0 hours, you get paid $0. You work 3 hours, you get 3 times however much you get paid per hour. Okay? So whenever we are going to relate the variables, so it says the variables x and y vary directly. Okay, so it's going to write an equation and then relate the variables, and then what you're going to do is you're going to find y when x is 8. So you're basically going to do essentially two things. You have to figure out what your k value is. You're going to rewrite your equation. And then what you're going to do is you're going to figure it out whenever x is equal to 8. You're going to plug in your value to your new equation. So like if I have, like on 43, where it says x is equal to 2 and y is equal to 7. So if we're going to do this one right here, I'm going to set it up just like I would up here. I've got to figure out what k is first. So if I have to figure out what k is first, I'm going to have 7 equals k times 2. How do I solve for k? Divide by 2. So if k is equal to 7 over 2, or if you want to call it 3.5, it's really up to you. It doesn't matter to me. Okay, so there's basically the first part. Your second part is really this easy, and I will have multiple students say, that's all we have to do? Yes, this is all you're going to have to do. is it'll ask you to write the new equation. Well, you're going to write y equals 3.5x. There's your second part. Your third part then is when you will now take your new equation and plug in 8 to that equation. So you find k, you write your new equation, and then the next thing is you're going to take whatever value they give you for x and you're going to plug it in. So I'm going to take y equals, I'm going to go 3.5 times 8. 3.5 times 8. How much? 28. There's my last step. All of these will basically have like 3 steps. Figuring out what k is, rewriting your equation, or putting it in an equation, and then saying, here's what happened. Okay? It's like if somebody said, hey, you got paid $7, you worked 2 hours. Write an equation for your hourly paying job that is terrible, not even minimum wage. Okay? Far from it. And then they say, well, what happens if you work 8 hours? Then that's where you plug in that 8 hours. Okay? Obviously, it's not realistic, but you kind of get the idea. Okay? So find k first. So if you need to write this somewhere, so find k. Rewrite your equation. Then plug in the given value. Now, the last thing you have to do as far as identifying if it's direct variation is to see basically if you would, one, make sure that if you start at 0, that you're going up by a constant value. Okay, that's where your k value is concerned. But like if you would work your way back, is it going to end up at 0? Is it going to be when x is at 0, is y going to be at 0? Okay? So as everything moves, like on the first one, I'm going up 2, so it's in there, right? What's happening to my y value every time I move basically 2 steps to the right? I'm going up 1, right? Now, if I go back 2 and I go back 1, am I going to end up at 0, 0? Yes. So is this going to be direct variation? Yeah, everything's good, right? What would be my equation? Like if it was y equals, what would it be? What am I multiplying by x every time to get my y value? Or better yet, slope, you're close, but you're backwards. 1/2. Okay? Because what I want to do is I want to take whatever my change in y is and divide it by whatever my change in x is. So it's going to be 1/2. Remember, slope, or m, is the change in y over the change in x. Your m, or your slope, that's the same thing as your k. So like if we look at one like 56, what's happening? Well, as I go up one, everything's great. My y values are going down one. Everything looks good. -1 over 1, -1 over 1, all the way throughout. What's the problem, though, with 56? If I go back one, as far as am I going to end up at 0, 0? No. If I go back one, okay, if I go back one to where x is at 0, and then I go forward one, then y is at 6. So does this fit direct variation? No. It's not that the slope just has to be the same. It's that I can't have a starting spot other than 0, 0. Okay? It's like an hourly paying job. If I work 0 hours, I should not get a check. I should get a check for $0. Okay? They're just going to give me $6 just because, okay, I'm a nice person. Okay, businesses don't work that way. Inverse variation, very similar, but instead, now I don't use A, I'm going to use K for everything. So instead of the A, make it a K. Instead of multiplying by K with X, I'm taking K and dividing X. Okay? Understand that this is different. Okay? Y equal to 1 over K times X is different than K over X. Does that make sense? Okay? What this is really essentially, if you would think about it in terms of like what it would look like in terms of direct variation, it's really 1 over X times my K instead of X over 1. Okay? Direct variation is X over 1. Inverse variation is 1 over X. Does that make sense? We still can't add anything, so we still can't have, I can't have y equals K over X plus 2. Doesn't work then. There's nothing that's going to get added or subtracted to anything. Okay? The same way, just like we talked about, like if as far as what it could look like, it could look like we could have K. Oh, never mind. Let me put it this way. If it starts out as like y over K equal to some x value, okay, or really 1 over x, that's okay. Right? As long as x is in that denominator spot, you're going to be okay. Or if you can get it in the denominator spot, that's okay. If it would be like x times y equal to 7, that would be a form of inverse variation. Because what would happen if I want to make this thing y equals? Divide by x, right? So I can make it y equals 7 over x. That's okay. Okay, because I can just send that x over to the other side by dividing it, and it would still be considered inverse variation. Yep. So then here on the second page it says, tell whether x and y show direct variation, inverse variation, or neither. What about the first one? Direct, inverse, direct. Everybody good with that? Yeah? What about 2? Inverse. Everybody good with that? I am. What about 3? Why? Like if I make this y equals, I'm going to have negative. What can I not have? If there was no 7 on the back end, would it be okay? Yeah, because it would be like a -1, right? Okay. So this one is going to be neither. Now, what about 4? Inverse, right? I just put that one on there. Okay, or one similar to it. Okay. Now, remember, y is an inverse because if I divide by x, I get y equals 5 over x, which is similar to, like, my k would be 5. Okay, so that's going to be an inverse variation. With the table, as far as checking to see, if it's direct variation, one can I get there? Is the slope going to be the same? Okay, so is the slope going to be the same? Like is 12 over 3 the same thing as 32 over 8, which is the same thing as 44 over 11, which is the same thing as 2 over 1/2. Okay, does that work? Or thinking about it this way, if I would go back to 0, can I get back to 0, 0? Okay, so like we've got to make sure that whenever I do this, like because I have these values that are varying from one to the other, have to first check to see is for it to be direct variation, is 12 over 3 the same thing as 32 over 8, which is the same thing as 44 over 11, and is that the same thing as 2 over 0.5? Okay, that's okay. Everything over there is divided is 4. Okay, but it's one of those things, if I go back 4, okay, or if like I look at the very last one, if I go back a half, normally in one step I go, okay, this is the same thing as 4 over 1. Is the change in y, if I go back 4, the same as going back 1, am I going to end up at 0, 0 on 11? Okay. Or if I'm at 0.5, if I go down 2 and I go back a half, am I going to end up at 0, 0? Okay. Think about it this way. If essentially, I mean, not really, but this is going to be the easiest way for you to see it. Okay? So like I have a point at 1/2, 2. Okay? I have another point at 3/12 that's going to be somewhere way up here. Okay? My other point that everything is basically up 1 over 4. If I would run through this, am I going to run through 0, 0? Yeah? Okay. Or like if you would need to put in like another table. Like if here's my x, if here's my x and here's my y, if I have a spot at I had 3 and I had 12. So if it's at 2, where am I going to be at? Yeah. So then I had like 1 and 4, right? So because my numbers are so sporadic, because if I had 4 and then that would be 16. If I had 5, I'd have 20. 6, and I'd have 24. The problem is I don't have all these values because it only goes from 3 to 8, right? So it's like if I would fill in all the blanks. If I go back to 0, where's this spot going to be right there? 0. Okay? So then, since it does end at 0, 0, and I'm counting by that constant value, then it's going to be direct variation. Okay? Whereas, like on 12, 12 should be one of those that should be fairly easy. Because if I go back from x and I go back to 0, what's my y value going to be? 7. So which one is that? Neither. Because if we go back 1, like if I try to fill in like this, like instead of it being an x and a y, like if x is 0, what's my y value going to be? 7. Like since it has to be 0, 0, does that make sense? Now, the easy way I would tell you with a table to find the inverse ones, okay? Whenever we have direct variation, we usually take y divided by x, and it has to be a constant value. Whereas if it's inverse variation, we already had y equals x as our k value, right? That's the same thing as saying y is equal to k over x for it to be inverse. You agree with that? So then if it's going to be inverse, what I need to happen, I need those values to multiply together to give me the same thing. So what's 3 times 1? 3. Okay. So basically if I have x times y, I have 3. What's 6 times a half? 3. What is 10 times a third?
3.
Very good, Maury.
I picked it up in the hallway when I heard 3 5 times in a row. You want coffee?
Now, same thing. What's 12? What's a quarter of 12? 3 again. Okay. Now, if we go back, if we would, like, what would be, like, if I would have 0, okay, for my x, I can't divide by x, so that's just going to basically end it right there. Okay. So, yep. Good question as far as it being like, does 0, 0 exist? No, because you can't divide by the 0 as far as my x value because it's no solution, or, you know, it's, you get an error. Okay. So really you're just checking to see if what you're multiplying by is going to give you that constant value. Okay? Now, whenever you find it...
So it was inverse?
Yeah, sorry, I didn't put inverse in there. So, whenever you're trying to rewrite your equation, you still do everything the same way just like you did before. You're still going to find k. You're going to rewrite your equation. And then plug in your given value. But instead of dividing your two values, go with the form of k is equal to x times y. So instead of, to find k, going y divided by x, go x times y. So like on number 8, okay, so if we do 8 here, Find k first. So what's 3 times 4? 12. Next step then is to rewrite my equation. So I'm going to have y equals 12 over x. There's step 2. So there was 1. Here was 2. Then it says to find y when x is equal to 4. So y equals 12 over 4. Y is equal to 3. Now, joint variation, and this is joint variation and direct variation are the same thing. It's just joint variation, you have 2 or more quantities. So it may be like z equals k times x times y. Okay? So whenever it says that z varies jointly with x and y, that just means that x and y are going to be on the top side of your function or equation. And jointly just means that it's going to be direct. That just means you're multiplying. It's essentially direct is multiply, inverse is divide. So if it says that Q or F or Z varies jointly with X and Y, that just means I'm going to have K times X times Y. The number is still your constant. Okay. Now, I will tell you, like, if you look at one like 16, as far as like how this one would be written, it would say that X varies jointly with Z and inversely with Y. Whatever it talks about at the beginning, so X varies. Okay? That's going to be whatever's in front. Joint, now it's not really joint, I guess it just varies with Z because there's not anything with it. But X varies with Z and inversely with Y. Whenever it says that something is inversely, that just means it goes down in the denominator spot. Laura, question? So like where it talks about the relationships here, okay? Anytime it says K is always going to be on top, okay? If it's direct or joint or jointly, it's essentially like Y equals K over X over 1. Anytime it talks about something being an inverse or inversely, that just means my K is over something. So like where it says like on D, it says Y varies inversely with the square of X. So Y equals, I'm always going to have a K, square of X, so X squared. Or like on E, where it says Z varies, so Z varies directly with Y. So where's Y going to be, on top or on bottom? If it's direct, it's on top. K is always on top. Y is on top. Where's the X going to go? On the bottom. Okay? So in terms of like my fraction, K is always on top. Direct is always going to be on top. And inverse is always going to be on bottom.
Did you say there's always a K in like all of them?
Yes. A K or a number. Huh?
Is it always on top?
Yes.
Like K is just like replacing it.
Yes. Or the numbers replacing K. Yeah, however you want to look at it. So whenever we write this, you're going to have your variable, whatever it is. Okay? So essentially whatever varies equal to K over your direct, and then whatever's on bottom is going to be your inverse. If you think about it that way. If you don't have anything that's inverse, it could be joint as well. Okay, so if it talks about anything jointly, then that's also going to be on top.
But if that jointly was the same.
It is. That's why it goes up on top.